Many consider man's single greatest achievement to be the discovery of time. Without this discovery, our ability to navigate spaceships in and out of Earth's orbit would be non-existent. It is our discovery of time and our understanding of orbital variations that has and will continue to mark the upward surge of mankind. With the Soviet Sputnik success in October 1957, Werner von Braun and his team successfully launched America's first spacecraft, the satellite Explorer 1. With the birth of NASA, the US space program had the dedicated resources it needed for the next great achievement, getting a human being into space. On the morning of July 16, 1969, almost the whole world was watching the Kennedy Space Center, where Apollo 11 was due to lift off. This had been John Kennedy's dream. Now was the moment of reckoning.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
As the incredible might of Saturn V lifted Apollo 11 clear of the tower and pierced the deep blue sky, it was a moment of pure awe. Right now, the hopes of millions of people rested on just three men: Neil Armstrong, Michael Collins, and Edwin Buzz Aldrin Jr. It would take them 4 days, travelling 250,000 miles to reach their destination. Despite the long wait, on Earth public anticipation remained high. Previous Apollo missions had been televised, and this was no exception. What was exceptional, though, was the level of interest. In what was probably the biggest news event in many years, countless people tuned in, travelling every step of the way with the astronauts.
Feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 20, down a half. 30 seconds forward. Just good. Okay. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
I'm at the foot of the ladder. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Aldrin, a spiritual man, joined Armstrong on the ground, describing the view as magnificent desolation. Now there was work to be done, but the moon's gravity was 1/6 that of Earth's, and the fine moon dust slippery, making it difficult to move around. The two men experimented with kangaroo hops, but their life support backups threw them off balance. Eventually, they settled for a loping gait, but had to plan all their movements ahead. Gradually, they got their task done with a 15-minute extension granted by Mission Control. They planted the American flag, collected soil and rock samples, took photographs, and set up measuring equipment. They also took a call from President Nixon, congratulating them on their achievement. With time up, they packed the 22 kilograms of lunar samples into the lunar module, jettisoned any unnecessary weight, and after a much-needed sleep, began their ascent from the moon. As the lunar module lifted off, the American flag Armstrong and Aldrin had so carefully planted in the ground was too close to the rocket exhausts. The flag was blown away and a lesson learned. Future landings made sure the flag was well out of harm's way. The Eagle's ascent from the moon had been the one area that could not be tested, but it proved to be easy, and they returned to orbit smoothly. After meeting with Michael Collins, the delicate manoeuvring of the rendezvous and docking took place. The Eagle's cargo was transferred to the command module, and the Eagle jettisoned. Now it was home time. Just before the sun climbed over Earth's horizon, the three astronauts splashed down 24 kilometers from the recovery ship. Drivers from Navy helicopters were on hand and anchored the command module so it couldn't drift off, and the astronauts were given quarantine suits. A welcoming committee awaited their arrival on Hornet, including President Nixon. Although it was not considered likely, the possibility of disease or pathogens being brought back from the moon was not something to take a chance with. The astronauts remained in their isolation suits and then entered the ship's mobile quarantine facility. At least now they were on their own soil and on their way home. In 1865, with astonishing foresight and accuracy, Jules Verne wrote From the Earth to the Moon. It inspired great minds who envisaged multi-stage liquid-fuel rockets and developed the rocket equation. During the 1930s, Nazi Germany pursued rocketry for warfare. They built the world's first ballistic missiles after a few setbacks. Werner von Braun produced Vengeance Weapon 2, the V-2 rocket that bombed Belgium, France and London, and was the forerunner of modern rocket propulsion. Post-war, he was employed in America, developing ballistic missiles. Later, working for NASA, it was his Saturn V rocket that launched Apollo 11 into space.
July 1st marks the beginning of one of the great scientific adventures of our time.
This was the beginning of the 18th-month-long International Geophysical Year. Harnessing the new technologies of rocketry and computers, 67 countries studied weather, the oceans and poles, seismology, solar activity, and the atmosphere. Both Russia and America launched satellites into space. On October 4, 1957, Russia's Sputnik 1 became the first man-made satellite in orbit. Every 96 minutes it orbited the Earth, collecting valuable atmospheric and radio signal information. It re-entered Earth's atmosphere and burned up after 3 months in orbit, having travelled 60 million kilometres. 1 month later, a second Sputnik was launched, the first spacecraft to carry a living creature. Despite a fault with the temperature control, causing the dog's death, Sputnik 2 was a great success for Russia. In America, it was a different story. Its Vanguard launch had failed, damaging the satellite and the launch pad. and it was the following year before its Explorer satellite was successfully launched. Russia's Sputnik success embarrassed America and sparked the government's decision to set up NASA. Following successful missions by Russia using dogs and America using chimps, the Russians took the next step. On April 12, 1961, 27-year-old Yuri Gagarin became the first human being in space. Standing just 5'2", this was probably the first time in his life he was glad to be short, clinching his selection to man the cramped space capsule. He completed a full orbit of Earth in 108 minutes and landed safely, deservedly a national hero. US President J.F. Kennedy felt great pressure to have the United States catch up to and overtake the Soviet Union in the space race. 4 years after the Sputnik shock of 1957, and with Gagarin becoming the first human in space, the US was greatly embarrassed. In addition, the Bay of Pigs fiasco in mid-April put unquantifiable pressure on Kennedy. He wanted to announce a program that the US had a strong chance at achieving before the Soviet Union. After consulting with Vice President Johnson, NASA Administrator James Webb and other officials, he concluded that landing an American on the moon would be a very challenging technological feat, but an area of space exploration in which the US actually had a potential lead. Thus, the Cold War is the primary contextual lens through which many historians now view Kennedy's speech. The decision involved much consideration before making it public, as well as enormous human efforts and expenditures to make what became Project Apollo a reality by 1969. Only the construction of the Panama Canal in modern peacetime and the Manhattan Project in war were comparable in scope. On May 25, 1961, US President John F. Kennedy announced before a special joint session of Congress the dramatic and ambitious goal of sending an American safely to the moon before the end of the decade.
The dramatic achievements in space which occurred in recent weeks should have made clear to us all, as did the Sputnik in 1957, the impact of this adventure on the minds of men everywhere. I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
America accelerated its efforts, preparing astronauts for the Project Mercury spaceflights. Just over 3 weeks after Gagarin orbited Earth, America launched its first manned spacecraft, piloted by Alan Shepard. It was a short 16-minute non-orbit flight, but an important milestone.
I think probably there hasn't been maybe enough emphasis on the real goals of our program, or the first, what we're trying to do on Mercury. Actually, we're trying to put a man in space so that we can determine what his capabilities are, what he can or cannot do in space, so that we'll know how to design future vehicles better for the man. Because some of these days we're going to have power plants that will enable man to go out in space and make decisions on where he wants to go and what he wants to do, much as we do in airplanes now. When we reach that stage, then man becomes not excess baggage, but he becomes a real vital, living, necessary part of this thing.
Colonel John Glenn was selected to make the first American manned flight, but the launch had been postponed several times. Finally, 10 months after Gagarin, it was his turn.
Five, 4, 3, 2, 1, 0. Ignition. Liftoff. We have a liftoff at 15 minutes after the hour.
In a flight lasting almost 5 hours, Glenn orbited Earth 3 times. Unlike the Gagarin flight, which was remotely controlled by ground staff, John Glenn had to take over manually, overriding malfunctioning automatic altitude and fuel controls. The descent to Earth was nerve-wracking. A sensor indicated the spaceship's heat shield was breaking loose, meaning the craft would incinerate during re-entry. An anxious crowd, including President Kennedy, awaited the moment of truth. The sensor proved to be faulty, and he splashed down safely in the Atlantic, slightly short of the planned landing zone, but to the relief of an entire nation alive. Russia and America both launched satellites as early as the 1950s, and in the following years, increasingly sophisticated measuring equipment gathered atmospheric data, enabling advanced weather forecasting. A global spread of satellites has revolutionized our way of life, with high-speed communications part of everyday living. NASA research was not confined to outer space. Extensive study and testing helped determine the effects of wind turbulence on aircraft, whether caused by other planes or natural forces. Also closer to home, high-altitude photographic surveys were undertaken towards developing remote sensing of natural disasters. The developments that grew out of the space program increasingly affected everyday technologies embraced by people worldwide. As time went by, the intense rivalry between the Soviet Union and the United States gradually eased, eventually leading to a more practical, cooperative approach to space exploration. But this was a long time coming, following several years when both battled the same problems, sought the same solutions, and conducted the same experiments. The difficulty was keeping man alive for several days, with limited air, water, and energy. This would prove to be crucial for the crew in the ill-fated Apollo 13. The concept of the Space Shuttle actually was formed in the 1950s, but design and construction of this very practical spacecraft was not begun until the 70s, and the first test flights begun in 1981. With over 2.5 million parts, it's considered mankind's most complex machinery. It had an enormously successful career as a spacecraft launched by rocket for orbital space missions, successfully launching satellites and space probes, carrying equipment and gathering research. The shuttle's special feature is that it is largely reusable, landing like a conventional aeroplane on a long runway. It's also had its tragedies: the loss of Challenger, which exploded just after launch, and Columbia, which disintegrated on re-entry. Both disasters were largely avoidable. Forerunner of the space station, Skylab was a dedicated scientific and research space lab. Designed to be manned for lengthy periods, extensive crew training and testing was carried out to ascertain humans' ability to cope in the confined spaces, and great emphasis was placed on creating a habitable environment. The idea of an orbiting laboratory was first conceived in the 1950s and finally came to fruition in 1973 when an unmanned Skylab was launched.
This year has been a big year for Skylab. All of the hardware for the program is coming into focus. Our qualification programs are underway. The major elements of the Skylab system are in the final positions of manufacturing and checkout. Now, one of the more important things to me about Skylab is it gives us an opportunity to learn more about man's capability to work and live in space.
The much-anticipated launch took place on May 14th, but did not go to plan. The meteoroid shield, which doubled as shade for the workshop, was ripped off by the atmospheric drag a little over a minute after takeoff. This also disturbed sections of the solar array, and the planned launch of the first crew had to be delayed until repairs were made, including a new insulation cloth to prevent overheating. Skylab's 3 crews stayed a total of 171 days, completing almost 300 scientific, technical, and medical experiments. Skylab paved the way for future stations like the International Space Station. Man's desire to explore the galaxies and seek out other planets is hardly surprising. From the beginning, human beings have been inquisitive creatures. We've always had the urge to explore territories and see what's around the corner. Man is a fortunate species. Over thousands of years, our intelligence has given us tools and technology, art and science, society and civilization. We now possess a treasure house of man's greatest achievements.